Bismillahirrahmanirrahim. Hi, how are you doing, guys? Let's complete chapter 5. The first problem. 55 kilogram box rests on horizontal surface. سطح أفقي. The coefficient of static friction between the box and the surface is 0.30. So mu s equals 0.30. And the coefficient of kinetic friction is 0.20. So mu k equals 0.20. What horizontal force must be applied to the box to cause it to start sliding? Cause it to start sliding means you need to calculate the forces that overcome the static friction. So F equals mu static Fn. So mu s and the normal force equal mg. So 0.30 times 55 kilograms times 9.8 equals 161.7, approximately 160 Newton as written on the model answer. As you see, we didn't use the coefficient of kinetic friction because if you want the box to start to move, you need to apply a force equal the friction force or static friction force. Let's go to the next one. Number 82. The coefficients of static and kinetic friction is between 3 kilograms, so you have the mass 3 kilograms. Box and a horizontal desktop are 0.40, 0.30 respectively, means mu s equals 0.40, mu k equals 0.30, because you know the coefficient of static friction is greater than the coefficient of kinetic friction. What is the force of friction on the box when 15 Newton horizontal push is applied to the box? So applied force is 15 Newton. Let's see if it is more than or less than the static friction. Let's calculate the static friction first. F mu s mg, right? Mu s is 0.40 times m is 3 kilograms times 9.8 equals 11.76 Newton. Hold on. You apply a force larger than the static friction force, right? So the box or the object or the box is moving now, right? Because you apply force more than the force of static friction. So the object is moving, so to calculate the force of friction, F equals mu k, because the object is moving, mg. Mu k equals 0.30 times the mass is 3 kilograms times 9.8 equals 8.82 Newton. Approximately 8.8 Newton. So the answer is letter B. I hope you got it, guys. Let's go to the next. An object slides on a level floor. It slows and comes to a stop with a constant acceleration of 2.4 meter per second square. So you have the acceleration is 2.4 meter per second square, and it is negative acceleration because it slows and come to a stop, right? What is the coefficient of kinetic friction between the object and the floor? Hold on. So the applied force exactly equal the force of a kinetic force, kinetic friction force, right? Or the force, friction force while the object is moving. So F, you know well that F equal ma and exactly equals mu k because the object is moving, mg. M goes with m, and A equal mu kg. So mu k, the kinetic friction, coefficient of kinetic friction equal A over G equal 2.4 over 9.8 equals 0.24, and it doesn't have unit. You know that the coefficient of kinetic or static friction do not have a unit. So the answer is letter A. Let's go to the next. A policeman investigating an accident measures the skid marks left by a car on the horizontal road. Guys, the marks done by the tires of the car. He determines that the distance between the point that the driver slammed on the brakes, thereby locking the wheels, and the point where the car come to a stop was 28 meters. So the distance equals 28 meters. From a reference manual, he determines that the coefficient of kinetic friction between the tires and the road under the prevailing condition was 0.3. So mu k equals 0.3 without unit, right? How fast was the car going when the driver applied the brakes? So you know that V final equals 0. You need to calculate V initial. Right, guys? So, you know well that F equal ma and exactly equal mu k mg, the force of friction. So m goes with m. So we need to calculate the acceleration. A equal mu k times g. A equals 0.3 times 9.8, so 2.94 meter per second square, and put in your mind it is negative sign because it is deceleration. He is slowing down until it stops, right? So to calculate the initial velocity, you know well that V final square equal V initial square plus 2AS. So V initial square equal V final square minus 2AS. V initial square equal V final 0 minus 2 times the acceleration negative 2.94 times the displacement 28 meter. Right, guys? So V initial square equal approximately 164.64. So V initial square root of this number equal 12.83, approximately 12.8 meter per second. So he determined the initial speed and it was letter B. You can convert it into kilometer per hour, guys. Do you know how to convert it? Guys, I want to know how to convert units. 12.8 meter per second multiply, if you want to make it kilometer, so kilometer 1000 meter times, if you want to change it second by hour. So 1 hour equals 3600 seconds. So just multiply times 3,600 and divided by 1,000, you will get the number in kilometer per hour if you like to know the exact number in kilometer per hour. Let's go to the next problem. 50 kilogram box is being pushed along a horizontal surface. You have a horizontal surface and you have box 50 kilograms, so M equal 50 kilograms. Is being pushed along a horizontal surface. The coefficient of static friction between the box and the ground 0.65. The coefficient of kinetic friction is 0.35. As you see, the coefficient of kinetic friction is less than the coefficient of static friction, as usual. What horizontal force must be exerted on the box? There is horizontal force, تمام? Exerted on the box for it to accelerate 1.2. So the object is accelerating, right? 1.2 meter per second square. So you need to overcome the friction force. Which type of friction force? Force kinetic, right? So as you see, MA equals the force here, the pushed force, F applied force, F applied, minus F friction, right? We can write it Fk because the object is moving, right? So F applied, he needs you to calculate F applied, mean equals Ma plus F, the friction force. So F applied equal M is 50 times the acceleration 1.2 plus mu K mg. 50 times 1.2 plus 0.35, the coefficient of kinetic friction, times 50 times 9.8 equals 231 point something Newton. So the number is here approximately 230 Newton, guys. So the answer is letter D. Let's move to the next one. A baseball player is running to a second base at 5.03 meter per second. So this is V initial 5.03 meter per second. When he is 4.80 meter from the plate, so S equal 4.80 meter. He goes into a side. The coefficient of kinetic friction between the player and the ground is, so mu K equals 0.180. And the coefficient of static friction mu S equal mu S, and the coefficient of static friction is 3.14. What is his speed when he reaches the plate? So he needs to calculate V final. You need to calculate the acceleration, right? You know that F equal MA and it equals mu K mg because the player is moving. M goes with M, so the acceleration mu K 0.18 times 9.8, so the acceleration is 1.764 meter per second square. And sure, it is negative acceleration or deceleration, right? Type. How to calculate the V initial? You know well that V final square equal V initial square plus 2AS. So V final square equal V initial square 5.03 square plus 2 times A negative 1.764 times S distance 4.8. So it equals Let's calculate it with calculator. 8.3665. So V final equal 2.89 meter per second. This is the final velocity and it is letter B. Let's go to the next. "55 kilogram box rests on horizontal surface. The coefficient of static friction between the box and the surface is 0.30, so mu s equals 0.30. A horizontal 140 Newton force is applied to the box, 140 Newton. What is the friction force on the box? Let's see if this force is larger or smaller than the static friction. So let's calculate the static friction. F equals mu mg, so 0.30 times m, 55 times 9.8 equals 161.7 Newton. So this is static friction. The maximum static friction. If you want the object to move, you need to apply larger than this amount of friction, but you applied 140. So the friction is only 140. Why? Because you couldn't overcome the static friction. So the friction that you face is equal to push force only, less than the maximum static friction. So the answer is A, 140. Got the idea, guys? I hope you got the idea. Let's go to next. Here is a horizontal 52 Newton force is needed to slide 50 kilogram box across a flat surface. This is a flat surface, and this is 52 Newton. At a constant velocity. Hold on, do you remember what we said about constant velocity? Means what? Means the amount of net force equals 0. Means the F applied equal F, the F for friction. So MA equals mu mg, right guys? So M goes with M, A equal mu g, right? Mu sg. But you don't need to get the acceleration, right? And you have the force, so let's return it as it was. And you have MA, it equals 52 equals mu s times, and it is not s, it is mu k. Why? The object is sliding. Times m. M is what? mg. mg. M is 50 kilograms, right? Times G 9.8, so mu K equal 52 over 50 times 9.8. Let's use the calculator to calculate it. It equals 0.11. So the answer is letter A. I hope it is easy. Let's go to the next. In a shuffleboard game, the puck, the small cylinder, the puck slides a total 12 meters, so you have S equal 12 meters on horizontal surface before coming to rest, so V final equals 0. If the coefficient of kinetic friction between the puck and board is So mu k equals 0.10. What was the initial speed? So you need to know initial speed. To know it, you need to calculate the acceleration, right? You know that F equal ma equal mu mg, mu k. So m goes with m, a equal mu kg, a equal 0.10 times 9.8 equals 0.98 meter per second square. So V final square equal V initial square plus 2AS. You need to calculate V initial square equal V final square minus 2AS. Right, guys? V initial square equal V final square, we said 0 minus 2. And as you see, it is deceleration, negative acceleration, right? Because the final speed is 0. So negative 0.98 times S, 12 meter. So the answer is 23.52. V initial equal square root 4.8 something, or 4.8 meter per second. 4.8 meter per second. So the answer is letter A. Let's go to the next. It is easy, guys. During a hockey game, a puck is given an initial speed. You know initial speed, the initial 10 meter per second. It slides 50 meter, so S equal 50 meter. On horizontal ice before it stops due to the friction. What is the coefficient of kinetic friction? You need to know mu k between the puck and the ice. Between the puck and the ice. How to calculate acceleration from this information, guys? Hold on. It stops to, so V final equals 0. You know well that A equal V final square minus V initial square over 2S. 0 minus 10 square over 50 times 2. So A equal negative 1 meter per second square. This is deceleration. And you know that the applied force MA equal mu K mg, right? M goes with M, so A equal mu kg, so mu K equal A over G, so 1 over, you will take the positive sign, guys. We know this is deceleration, right? But when you apply here A, you will use the positive number over 9.8. 1 over 9.8 less than 1, 0.1 or 10. Check it, guys. So the answer is 0.10, letter B. Use the calculator and check it. Let's go to the next. A driver in 1,000 kilogram car, he gives you the mass traveling at 24 meter per second, slams the brakes and skids to stop. So V initial equal 24 meter per second, V final equal 0. If the coefficient of friction between the tire and the level road is 0.80, so mu K equals 0.80. How long? Here he needs how far will the skid marks, because the answer in meter. So he needs S. Can you calculate the acceleration first? You know well that F equal MA equal mu K mg. So M goes with M, so A equal mu kg equal 0.80 times 9.8. So acceleration equal 7.84 meter per second square. you need to calculate the distance. You know well that V final square equal V initial square plus 2AS. So S equal V final square minus V initial square over 2A. So S equal V final square is 0 minus V initial square 24 square. My 2 times, it is deceleration, so you will use the negative signs, 7.84, right? So S equals, let's use the calculator, 36.7 meter, approximately 37 meter, guys. The answer is letter A. Let's go to the next. Jason takes off across level water on his jet-powered skis. The combined mass of Jason and his skis is 75 kilograms, so you have M equals 75 kilograms. The mass of the fuel is negligible. The skis produce a forward thrust of 200 Newton. And so F thrust equals 200 Newton. And have a coefficient of kinetic friction with water is of, so mu k equals 0.10 with water. Unfortunately, the skis run out of fuel after only 90 seconds, so T equals 90 seconds. What is the Jason top speed or the final speed? Vf. Okay, guys? And sure, he starts from rest, so V initial equals 0. So, this is the skis, and this is Jason, and this is the thrust forward force, 200 Newton. This is the F friction, and he moves this way, so this is the Fx or F. So MA equal F thrust minus F friction force, right, guys? So MA equal 200, the thrust force, minus mu mg, right, guys? So A equal 200 minus mu is equal 0.10 times 75 times 9.8 over 75, the mass. So A equals, let's use the calculator, 1.68 meter per second square. Now it is easy to calculate the final velocity. V final equal V initial plus AT. Always we use the equation of motion, guys. Don't forget it. V final equal 0 plus 1.68 times T 90 seconds. So it equals 151.8, approximately 150 meter per second. So we have this speed, yes, letter A. Let's go to the next problem. You push horizontally on 120 Newton box. This is the weight. This is the weight of the box that is initially resting on horizontal table. The coefficient of static friction between the box and the table is 0.75, mu is 0.75, and the coefficient of kinetic friction 0.40, mu k equals 0.40. Find the friction force on the box. If the push is equal to 84, let's calculate the friction force while the object at rest. So mu s mg equal mu s 0.75 times mg at all, it is the weight, 120. So the friction force equal 90 Newton. Hold on. It is 90 Newton. For letter A, the push force is less than the static friction force, less than the maximum static friction force. So in this case, the friction force will be what? Will be only 84, the forces that you are using. Type. For letter B, as you see, for B, the push force is larger than max static force. So the object is moving. So F friction equal mu K times mg. So mu K is 0.40 times mg 120. So 0.40 times 120, it equals 48 Newton. This is the friction force. As you see, the friction force comes less while the object is moving. I hope you understand this idea, guys. It is important. Let's go to the next problem. An ornament, زخارف, of mass, he gives you the mass, is attached to a vertical ideal spring. Vertical ideal spring. This is the ornament. With a force constant spring, so K equals 20 Newton per meter. The ornament is then lowered very slowly until the spring stops stretching. How much does the spring stretch? You need X. You know well that F from Hooke's law, Kx. F here, the applied force exactly equal mg. So 40 times 9.8 equal K, 20 Newton per meter times X. And this is in Newton, right? So X equal 40 times 9.8 over 20. So, and this is 20 Newton per meter. But hold on, the mass here in grams, so 40 over 1000 to make it in kilograms, so 0.040. So instead of 40, 0.040, and here 0.040. So the answer is, because it must be in kilogram, guys, the answer is 0.0196 meter, because here is in Newton and here Newton per meter, so the answer is meter. Do we have this answer? Yes, letter B. Take care, because the mass here in gram, you need to convert it into kilograms. Let's go to the next. An easy one, guys. A force of 30 Newton stretches a very light ideal spring 0.73, so this is X, from equilibrium. What is the force constant? We need K. You know that F equal Kx from Hooke's law, so K equal F over X. So F 30 Newton and X 0.73. So the answer is 41 something or 41 Newton per meter. So the answer is letter A. Let's go to the next one. A very light ideal spring stretches 21 centimeter when it is used to hang 135 Newton. So this is X1 and this is F1. What is the weight of a piece of electronic equipment would stretch? So he needs F2 stretches the spring for 44.9 centimeters. This is X2. So F1 135 make extension or elongation 21 centimeter. What is the force that make stretching 44.9 centimeter? You can use the cross, means F2 equals 44.9 centimeter times 135 Newton over 21 centimeter. Centimeter goes with centimeter. We can calculate F2. Use the calculator. It equals 288.6, approximately 289 Newton. 289, so the answer is letter A. Let's move to the next one. An object attached to a spring is pulled across horizontal frictionless surface. An object attached to a spring is pulled over a horizontal friction surface. If the force constant he gives you K 45 Newton per meter, and the spring is stretched by, so X equals 0.88, so you can calculate the F. F equal Kx equal this meter, so 45 times 0.88 equals 39.6 Newton. When the object is accelerating 1.4 meter per second, what is the mass of the object? So you can make like that, F equal ma, and you have the force, so 39.6 equal m times the acceleration 1.4. So m equal 39.6 over 1.4 equals 28.2, approximately 28 kilogram, and it is letter A. Let's go to the next. A very light ideal spring having a spring constant or force constant 8.2, so you have K equal 8.2 Newton per centimeter, guys. Is used to lift 2.2 kilogram. You have mass 2.2 kilogram tool with an upward acceleration. So there is acceleration. Imagine that this is the spring and this is the tool 2.2 kilogram, and this is mg, and there is upward acceleration F, right? And because of the weight, there is force for the spring. Try to return the spring to its equilibrium position. If the spring has negligible length when it is not stretched, how long it is? He asked how far it is will pulling the tool upward. He needs the X that will go upward. So let's analyze the forces here. You have F ma in y direction equal F spring in the same direction minus mg. So F spring equal ma plus mg equals MA plus G. Right, guys? And if S equal Kx equals M times A plus G, right? So X equal M A plus G over K. Let's calculate it. M in kilogram, right? 2.2. A, the acceleration. He gives it 3.25 plus 9.8 over K. K is 8.2 Newton per centimeter, and this is in Newton, so Newton goes with Newton, so X in centimeter. Let's use the calculator to calculate it. It equals 3.5 approximately 3.5 centimeter. So the answer is 3.5 centimeter. Let's go to the next. Here is a very light ideal spring with a spring constant, force constant 2.5 Newton per centimeter. So K equal 2.5 Newton per centimeter. Pulls horizontally on an 18 kilogram, so the mass equals 18 kilogram. That is resting on horizontal floor. The coefficient of static friction between the box and the floor, so mu S equals 0.65. And the coefficient of kinetic friction, so mu K equals 0.45. How long is the spring? Just as the box is ready to move, so it is not moving. So for letter A, Fs equal mu S mg, it is not moving. Right, guys? It equals 0.65 times 18 times 9.8. It equals 114.66, and this amount exactly equals the spring force. So F equal Kx. So X equal 114.66 over K. K 22.5 Newton per centimeter, and this is in Newton. So the answer in centimeter, it equals 45.8, approximately 46 centimeter, and this is letter A. Let's go to letter B. If the spring pulls the box along with constant forward velocity, so the total force equals 0. So, and it is moving, so the forces that we use, we will depend on the kinetic friction, right, guys? So F equal mu K mg, so 0.45 mu K times 18 times 9.8 equals 79.38, and this is exactly equal Kx. So X now equal 79.38 divided by K, same amount. This is in Newton. This is Newton per centimeter. So X in centimeter will be 31.7, approximately 32 centimeters. So this is letter B. Let's go to letter C. For letter C, how long is the spring if it pulls the box forward at constant speed? He gives you a specific number. Constant speed means the total amount of force equals 0, like the one before. So you will get the same distance or the same elongation هو 32 centimeter like the previous one, because you have constant speed, so you apply the same rules as letter B. Let's go to the last problem in this chapter. A very light ideal spring of spring constant, he gives you spring constant K equal 2.5 Newton per centimeter, is 15 centimeter long. This is the long of the spring. This is the long of the spring, 15 centimeter. When nothing is attached to it, it is now used to pull horizontally 12.5 kilogram. You have M 12.5 kilogram. On perfectly smooth horizontal floor, there is no friction. You observe that the box starts from rest, so V initial equals 0, and moves 96 centimeters, so X it moves, or S, whatever you want to use the symbol, S equal 96 centimeters. During the first 1.6 seconds, so T equals 1.6 seconds of its motion with constant acceleration. At the beginning, it was at rest, so V initial equals 0. How long is the spring during? He needs the spring with elongation, with the extension, with the stretching. So at the beginning, you need to calculate F equal MA. He gives you A. No, so we need to calculate A, right guys? So X equal V initial T plus half A T squared, this is 0, so X A equal 2X over T squared, 2 times 96 centimeter. Let's write it in meter to get the acceleration in meter per second square. So 0.96 divided by 100 to convert it into meters. And the time 1.6 square. So acceleration equals 0.75 meter per second square. I got the acceleration. So now I can calculate F equal MA equal 12.5 times 0.75 equals 9.375 Newton. Right, guys? But you know that F equal Kx, right? So 9.375 equal K, 2.5 Newton per centimeter times X, right? So X equals 9.375 divided by 2.5 equals 3.75 centimeter. I'm using calculator quickly, guys. So this is the extension, the stretched part. What about the original length? He needs how long the spring during the motion. So the length equal the old length plus X. So 15 plus 3.75 equals 18.75, approximately 19 centimeter. This is the length or how long the spring during this motion. So we finished the problem that we have in chapter 5. People asked me to write the equation that I'm using, guys. You need to memorize the equation that for motion in one dimension, V final equal V initial plus AT, and this you can convert it like that, A equal V final minus V initial over T, or depending on what you need to calculate. Another one, V final square equal V initial square plus 2AS. V final speed, V initial speed. S is the distance or displacement. Or you can write it like that. 2AS equal V final square minus V initial square. Another one. S equal V initial T plus half AT square. V initial speed, T is time, S is displacement, A is acceleration. Also for the force, F equal, or the net force equal MA. Also for Hooke's law, F equal Kx. This is the equation that I used in solving the 100 problems for chapter 5. But you need to read the problem in details and don't forget any information given in the problem. God save all of you. God bless you guys. السلام عليكم ورحمة الله وبركاته. كان معاكم مستر إبراهيم سلطان فيزيكس اند